Hi, my name is Manish Gupta, and in this video, I'm going to talk about these few models T0, T0 plus, T0 plus plus, BLOOMZ, and mT0. All of these models are based on the concept of multitask prompted fine-tuning. So that is what I'm going to talk about in this video. Let's start by asking what is this multitask prompted fine-tuning, and then what is zero-shot generalization using multitask prompted fine-tuning. This is a project by BigScience, which is itself an open research project run by 600 researchers from 50 countries and 250 plus institutions. So in short, it's a massive effort. Um, the question that they try to solve in these two papers that I'm going to talk in this video is this: can zero-shot generalization be directly induced by explicit multitask learning? Okay. Multitask learning has been a popular way of doing learning in natural language processing. However, how do you do explicit multitask learning by prompted fine-tuning is what we are going to discuss. The idea is that the base model for all of these things that we'll discuss typically is going to be an encoder, pre-trained encoder decoder model, which is LM adapted, language model adapted. So for the first part of the video, at least we will talk about a pre-trained model that is the base of it all, right? It is the language model adapted T5 model, and it comes in two versions, 3 billion and 11 billion. So we will see results on both of them. Um, the idea is to take the T5 model and then fine tune it for many tasks using prompted form of multiple NLP tasks with diverse wording. So the idea is that let's say you have so many interesting tasks, summarization, sentiment analysis, question answering, all of them need to be done using a single model. How do you do them? Well, you basically express those tasks as prompted templates. We will also see in more detail what these prompted form means. But the idea is very simple. Let's say there is a sentiment analysis task. Then the input is going to be something like this. There's going to be a standard word called review colon. And then you have a review. We came here Saturday night and blah, blah, blah up to here. And then there'll be some standard words like on a scale of 1 to 5, I would give this a, right? And then you would basically the hope is that the model will come up with an answer 4. Right? Of course, the answers can differ based on the tasks. So as you see, for summarization, the answer could be a summary. For question answering, the answer is the real answer, and so on. Right? So you train on the prompted versions of some of these tasks in English only. And the hope is that after you have trained on these tasks, you take some another task which you have not trained on. So that is why it is zero shot. Okay? So you take some other task at test time. This is train time, this is test time, right? So you take some other task at inference time or at test time, and then the hope is that the model generalizes to this new task. So the idea is zero shot generalization, meaning being able to do another task directly using multitask learning, which has been done using prompts, right? So essentially you take several tasks, express them in different prompt formats, and give them as input. Now, depending on what all tasks have been used to train these models, there are three different models, T0, T0 plus, and T0 plus plus. And also, if you bring in multilinguality in picture, those models are BLOOMZ and mT0. And we will discuss details of BLOOMZ and mT0 later, but then at least for the English versions, the base model is the LM adapted T5 model. Now let's talk a little bit about the unified prompt format. So as we discussed, all of these tasks involve multitask. All of these models involve multitask learning using prompted inputs, right? So what does prompt mean? So prompt basically means two things: input template and target template. That's what a prompt consists of. So there is a input template and there's a target template. Now, in their work, they have restricted the input template to be 1,000 tokens approximately, and target template to be 256 tokens. Right? So what does input and target template mean? So well, look at this example. This is a Quora questions paraphrasing problem where, given two Quora questions, you have to identify whether they are paraphrases or not. So the idea is that the data is like this. Well, there is a question 1, there is a question 2, and then there is a label associated, right? So how is air traffic controlled? How do you become an air traffic controller? Are they paraphrases of each other or not? Depending on that, the label is going to be 0 or 1. Now, the idea is the same task can be expressed in several prompt formats, not just one. Okay, these are two possible prompts, right? So the first prompt basically just puts question one, question two together, and then asks pick one. These questions are duplicates or not duplicates. Yet another way of formatting the prompt is the following input template, right? I received the questions, question one, question two are the duplicates, right? In both the cases, the target is basically just a choice over possible labels, right? But then the input prompt could be different. In fact, here is another example of an input prompt for the same task. I'm an administrator on the website Quora. There are these two posts, one that asks question one and another that asks question two. I can merge questions if they are asking the same thing. Can I merge these two questions? Now, different wordings, different kind of prompts, but the task is exactly the same. Okay. So here is another example for the NLI task, natural language inference task, where the idea is given a premise and a hypothesis. You have to basically, you have to predict, the model has to predict the label, entailment, contradiction, or neither. So now, here the input is going to look like if premise is true, is it also true that hypothesis? Okay. Now, the target template, of course, is going to be choices over labels, but then the labels are going to be three in this case: entailment, neutral, or contradiction. Right? So that's how people can convert any NLP task for that matter into a unified prompt format, whether it is Quora questions task or NLI task or even summarization task, where prompts where human looking prompts could be something like this. Here's a document, and how do you rephrase that in a few words? First, please read this article, which is a document, right? And then now, can you sort of write me an extremely short summary for it? Right? So that is what the unified prompt format looks like. Now, as we discussed, for English, these guys basically train three different prompted multitask models: T0, T0 plus, and T0 plus plus. In fact, the tasks that are included in training these models are shown right here. And the data sets comprising these tasks are actually called as the P3 dataset. Okay? So together, it's basically just called as P3 dataset. Now the tasks here so yellow ones, as you see, are essentially used for training, and the green ones are used for testing or for evaluation. Yeah. So for each of those tasks, what you see is a bunch of data sets from where the overall P3 data set has been collated. So there are tasks of different variety, like closed book question answering or multi-choice question answering, extractive question answering, topic classification, paraphrase identification, summarization, sentiment analysis, structure to text kind of tasks, and so on. Right. While the remaining tasks that are used for evaluation are these four: sentence completion, NLI, co-reference resolution, and word sense disambiguation, and then a whole bunch of tasks from the Big Bench benchmark. Right? So overall, this P3 data set, which is used for fine tuning the T0 model, this is note that this is for T0 model only. For T0 plus and T0 plus plus, in fact, there are more tasks which have been used and more data sets which are part of the overall P3 data set. Okay. So for T0 itself, there are 12 tasks and 62 data sets which have been, with publicly contributed prompts. So note that, these prompts are not automatically generated. These prompts for each task, there are several prompts, on average around 8 prompts, right? For example, here itself, see that there are 3 prompts for QQP dataset, right? 1, 2, and 3. So similarly, several people have contributed different prompts. And then these particular data sets, they come with the human generated prompts as well, and that forms our P3 data set. Okay. These data sets are a part of all the data sets which are used here are a part of Hugging Face datasets library, so that you can directly access them. So they are publicly available. Now for T0 plus and T0 plus plus, they add more data sets. So for T0 plus, you add GPT-3 eval data sets also. For T0 plus plus, you add superglue data sets. Okay. This particular table actually shows you a comprehensive picture of what all data sets have been used for T0 training, T0 plus training, and T0 plus plus training. As we notice, for T0 plus training, these yellow ones that you see on the left side are the ones that you see with the tick mark here. For T0 plus training and T0 plus plus training, you see there are more tick marks. So more of those data sets have been used for training those models. That's that. Now with P3, data set that we discussed on the previous slide, you do English multitask fine tuning, right? So you take the T5 plus LM model, you take these prompts which have been manually generated for each of those data sets and each of those tasks. And then you train and then you fine tune the model. That's called multitask fine tuning, right? While generating these prompts, the labelers were asked to generate prompts which are grammatically correct and understandable by a fluent English speaker with no prior experience of the task, right? So the speaker may not know about the task at all. So therefore, the prompts are not supposed to be designed as, hey, this is an NLI task. Here is the premise. Here is the hypothesis. Predict the label. No, not like that. It has to be much more human oriented from a non prior knowledge perspective, right? That's that. Now, prompts that require explicit counting or any numeric indexing have been removed and rather have been replaced by natural language variants. For example, question answering can be considered as a task where you predict the span, the start index and the end index in a large passage for answering a particular question. But then they converted that task to actually predicting the actual text rather than just the start and the end index. Right? Most prompts correspond directly to a version of the original proposed task, but then some of them include permutations. For example, you could say generate a document from its summary rather than just summarize a document, right? Similarly, you could take a question answering task and then come up with a prompted version which asks to generate the question rather than coming up with the answer, right? These prompts were generated by 36 contributors across 24 institutions in 8 countries. So it's a pretty rigorously made data set. The data set is publicly available for anyone to use. Okay. On the other hand, in another paper, there is also an effort to train these models on multilingual data sets now, or multilingual tasks, right? So as you see, they train 2 models, BLOOMZ and mT0. And then the kind of prompted data set that is created is called as the XP3 data set. So remember that this data set contains multilingual tasks as well. So as you see here, yellow ones again are the data sets and tasks which are used for training, and the green ones are the ones which have been used for held out for evaluation. Also, you see some of them have been highlighted in bold. So these are the ones that have been added extra for multilingual purpose, right? So the ones which are not highlighted in bold are the ones which have been carried forward from the P3 dataset, and the datasets that were added to the P3 to come up with this new dataset now called as XP3 are basically highlighted in bold, right? And they have been used to do multitask fine tuning for BLOOMZ and mT0 models. A little bit more about this XP3 dataset. Well, as we basically discussed, it contains more tasks and more datasets compared to P3 because it brings in multilinguality, right? In fact, it brings these 4 new task clusters. So if we look at this picture again, there are these 4 new task clusters: program synthesis, code, miscellaneous code-based tasks, translation, and simplification. So it brings in these 4 different new clusters of tasks compared to the P3 dataset. XP3 basically is multilingual in nature, so it contains 46 natural languages and code. So it also has some code-based tasks, the actual formal code-based tasks, as the roots data set, which was used to train the original Bloom model. Right? So in fact, 39% of XP3 data is English data. So as you see here, right, which is slightly more than 30%, which was there in roots. Okay. So that's that, and also the point is that here is the language distribution. This language distribution sort of looks at 46 different languages, right, which are shared between XP3 and the roots datasets, right? So remember, roots dataset was used to train the Bloom model, and XP3 dataset has been used to train the BLOOMZ model, and as we will see soon, BLOOMZ and mT0 models, right? This is also being compared with the MT5 corpus, which was, of course, used to train the MT5 model. Now, of course, for MT5 corpus, it contained even more languages, but this chart basically shows for 46 languages the distribution across these 3 different data sets. And as you see, the dataset XP3 dataset closely mimics the roots corpus. and has pretty similar kind of percentage distribution across different languages. So note that for all of these in the XP3 data set in general, there are only English prompts. So however, people also wanted to figure out what if you provide multilingual prompts. How do the models behave if you do multitask fine tuning using multilingual prompts even for multi language tasks, right? So to study the importance of these multilingual or non-English prompts, basically the authors also created another data set called as XP3MT. And XP3MT is a very simple data set, just takes XP3 data and constructs a machine translated version of XP3, right? So you take those prompts, which are in English, translate them automatically in an automated machine translation way, and that gives you XP3MT data set. Right? Now we have talked about tasks, we have talked about data sets, we have talked about the broad concept that we want to do multitask learning and that too in a multilingual way as well, using prompted training, right? Now let's look at the results. What do people get when they do this, right? In fact, in the beginning, let's focus on English only results, right? So specifically talking about T0, T0 plus and T0 plus plus models, right? The question is, does multitask prompted training really improve generalization to held out tasks? Meaning you're trying to, remember there's no multilinguality here. So you're just trying to figure out zero shot task generalization, right? Hey, if I train it on in a multitask manner with prompted training on some tasks, does it improve the performance on other tasks? Okay. So here you see there is on the left picture, there is comparison with GPT-3 models of different sizes. This comparison with T5 model, T5 plus LM, which is the language model adapted T5 model. Remember, T5 model is just trained on next word prediction on the masked language modeling kind of a loss. Hey, but it's good to also train further on next word prediction loss. That is why a T5 plus LM model is used as a baseline here. And then you compare it with the T0 model. Okay. So the T0 model is a 11 billion parameter model. If you notice, it's way smaller than this GPT-3 175 billion parameter model, almost 16 times smaller, right? But the T0 model is the one which is basically trained in a prompted multitask manner, right? Across different tasks, NLI, co-reference resolution, sentence completion, word sense disambiguation, and across different data sets, what do you observe? You observe that T0 is actually better than all of the GPT-3 models. You see each of those GPT-3 models, the T0 model is better. T0 model is way better compared to any of those GPT-3 models. Okay. On 9 of those 11 held out data sets. So there are 11 of them which are shown in this picture, right? Out of them, 9 of them, the T0 model is better than any of the GPT-3 models, even though it is 16x smaller than the largest one, right? Also notice that for GPT-3 models, there is only one bubble that you see, but for T0 models, you see several bubbles. And that's basically because, remember, in the T0 dataset, there are several prompts which have been manually prepared for each of those tasks. So you see a bubble per prompt. So there is sort of one bubble per prompt that you see there, right? Similarly, you see one bubble per prompt for the T5 plus LM model, but the idea is that for GPT-3 models, you basically see only one bubble because GPT-3 just comes with one prompt. Okay. Now, what you also observe is that T5 plus LM is significantly worse, compared to sometimes even GPT-3. So it doesn't really even perform as good as GPT-3. For example, look at this one, or look at several pictures where it is significantly worse compared to even GPT-3 model. Now, interestingly, if you try on big bench evaluation datasets, you observe something similar. At least one of the T0 variants outperforms all baseline models. So what are the baselines here, right? So as you see here, several models have been plotted. The LM baselines. So these LM baselines are the other models that have been provided by the big bench maintainers, right? So in the big bench paper, if you look at it, whatever are the best performing methods, they have been shown here. Then you also compare with, of course, T5 plus LM model, which was the pre-trained, which was the initial model that has been used to fine tune the T0 plus and T0 plus plus models. And then The T0, T0++, T0 plus models are shown in green. So what do you observe? You observe that at least one of those T0 variants is better compared to any of the baseline models on 13 out of 14 big bench tasks. And lastly, of course, T0 plus is typically better than T0 plus, which is in general better than T0 model. Okay. So basically saying yes, multitask prompted training improves generalization to tasks that have never been seen while fine tuning. Okay. What happens if you increase the number of prompts per data set, right? So remember, these guys asked people to generate several ways in which the model can be prompted to solve a particular problem. Now, if you train it with just one way versus you train it with, let's say, several 8 ways, right? Which one basically gives you better results, and how does this look like? Yeah. So to verify prompt robustness, in short, they did two kinds of experiments. They varied the average number of prompts per data set while fine tuning, right? And the other thing they did was to vary, of course, the number of data sets that are used for multitask fine tuning, meaning T0, T0 plus, and T0 plus plus. Okay, so let's talk about the first thing first. What happens if you vary the number of prompts per data set? Okay, so remember, you could basically use all 8.03 prompts that were generated or that were labeled by humans. People came up with 8.03 prompts on average per task. Or you could basically just go ahead with a non-prompted version. So there is no prompts, it's just T5 plus LM model. Basically no prompts were used, no prompting. Okay. Or you could use one randomly selected prompt out of those eight different prompts, right? Or you could basically just use 5.7 prompts because 5.7 were original task prompts while on average across tasks, while 8.03 are average number of prompts if you include the non-original task prompts also. Remember we said that, hey, question answering can also be prompted as a question generation task, or summarization can be prompted as document generation task from summary. So if you include those variants as well, on average, there are 8.03 prompts. If you exclude them, on average, there are 5.7 prompts. You could basically use different number of prompts per data set, right? And across different data sets, across tasks, what do you observe? You observe that performance, of course, improves as you increase the number of prompts. Okay. Typically, you see this trend. The performance is increasing as you increase the number of prompts. That's beautiful, right? The other thing that you observe that in general, most of the times, as you increase the number of prompts, the variance reduces. The variance in terms of the behavior using different prompt techniques, that sort of in general reduces. It's not true everywhere, but in general, you see the variance is reducing as you are increasing the number of prompts being used. Okay, that's that. Now, what happens when you move from T0 to T0 plus, T0 plus plus, right? When you increase the number of data sets that have been used for multitask fine tuning, right? So just to recall, T0 is the smallest, rather the model trained with the smallest number of data sets, 39, T0 plus on 49, and T0 plus plus on 55 data sets. Okay. What you observe is in general that the median performance increases with D. So, as you notice, in general, you see median performance is increasing. Yeah, I mean, once in a while, this rule sort of gets broken, but in general, you observe that T0 plus plus performs the best, right? However, you cannot really say much about the variance. So the variance is not like, the variance for this guy is the smallest. Sometimes the variance for T0 plus plus is pretty high compared to T0 itself. Okay. So that's about the learnings from English multitask prompted fine tuning. Now let's talk a little bit about multilingual multitask prompted fine tuning, right? So remember, multilinguality is being brought in picture, and remember we also talked about XP3 data. So here two models make sense: Bloom and MT5. Why? Because Bloom is more like a multilingual version of GPT, right? And MT5 is MT5 multilingual T5, right? So it makes sense to start from these kinds of models, the training part. Remember, Bloom is a decoder-only model, decoder-only pre-trained model, and the model sizes vary from 560 million to 176 billion parameters. Okay, while MT5 is an encoder-decoder model. In Bloom, you fine-tune with the loss only being computed on the target tokens. Of course, in MT5 also, you sort of try to compute the loss on the target tokens on the decoder side. Right? In Bloom, inputs are space separated from the targets because everything is just being passed to the decoder. In MT5, it is more natural that the inputs are passed to the encoder and you get outputs from the decoder side. Now in Bloom also, or rather in both in Bloom and MT5, what is also done is to ensure that you normalize the loss dependent on the length of the target, because in different tasks, there are so many tasks which are being used for doing multitask fine tuning. And the length of the output can vary from just one to hundreds of tokens. And therefore, it's very important to make sure that you normalize the loss appropriately so as to avoid any bias towards longer or shorter tasks, shorter target tasks. Now, based on all of these, and based on the tasks that we discussed in the XP3 part, based on these tasks and these data sets, uh, three different variants were trained. Okay, I mean, multilinguality brings in these different notions in which you can use the multilinguality aspect, right? So BLOOMZ P3 and MT0 P3 are models that have been fine-tuned on English only data, the P3 data only. Remember, the P3 data is English only data. Okay. Now, why would you want to do that? You want to do that because you want to understand that do multilingual tasks do they also benefit from multitask fine tuning only on English data? That's the idea, and that is why you train models. Bloom Z model, and you call it Bloom Z model, right? And MT0 model, which has been trained only on English prompted multitask fine tuning. Okay, that's that. Now, and that too, small version of the data, P3 data. Okay. Now you also fine tune it on XP3 data. Remember what is XP3 data? It still has prompts which are written in English. However, tasks could be multilingual tasks also. Okay. So you're actually fine tuning on XP3, which contains multilingual data sets, but prompts are English only. Okay. So, and then lastly, we care about these kinds of tasks which essentially are fine-tuned on XP3 MT, or these kinds of models which are fine-tuned on XP3 MT, which consists of multilingual data sets with English and machine translated prompts. Okay? So the idea is that here it's English tasks and English data sets, English prompts only. Here it is multilingual data sets, but English prompts. And here it is multilingual data sets and multilingual prompts because they are obtained from in a machine translated manner. Okay. Now, you do evaluation on these three different on data sets belonging to these three different tasks: co-reference resolution, sentence completion, NLI, and so on. And then the idea is here in this particular work on the multilingual part, they do not vary the number of prompts. They just fix 5 prompts at random, and they select those 5 prompts from the data set that we just talked about, manually curated data set. And they also do for XP3 MT, they basically just do machine translation. So translate those prompts. Okay, automatically. So what do the results look like? Okay, so you see results here, on 3 different tasks: sentence completion, NLI, and co-reference resolution. Okay. You also see results based on 6 different models here. Okay. XGLM, Bloom, MTK. MTK is MTK instruct model. So these are all state-of-the-art, very powerful models. Okay, one of them is basically this Bloom itself, as you see. Okay. MTK instruct is better than MT5 as they claim. Right. And then what are these? These are basically BLOOMZ P3. Remember, trained on English data sets, English prompts, right? BLOOMZ model, which is basically English prompts but multilingual data sets, right? And then MT0 13 billion, again English MT0 13 billion, which is basically English prompts but multilingual data sets. So what do you observe here? You observe that this multilingual multitask prompting helps significantly, compared to the typical models that exist, the state of the art, the ones that don't use this multilingual multitask prompting at all. Okay. So what you observe is that even for multilingual tasks, if you just do English-based English prompting-based fine-tuning, multitask fine-tuning, that helps. Okay. So fine-tuning on just English data, English only data with P3, right? BLOOMZ P3. See, I mean, that leads to better performance on non-English data, on multilingual data sets. So you see, this 80.5 is significantly better compared to any of these, right? So that's that. And remember, this has not been fine-tuned on on neither on multilingual data sets nor with multilingual prompts. English data sets, English prompts, the same P3 data sets, right? Just fine tune on that. But you see, on multilingual tasks, these sentence completion, these are all multilingual tasks. You see, on these tasks also performance improves. That's magical. I mean, you never told it about this language, you never told them about these data, these tasks, but still the performance improves, and that too significantly, a huge boost. You see, yeah. The other interesting part is that if you compare the MT0 model with the BLOOMZ model, remember both of them have been trained using a similar philosophy, right? They have been trained using the XP3 data. So although MT0 model has 13 billion parameters, BLOOMZ has 176 billion parameters, still MT0 is better. You see, the performance of MT0 is typically better across all of these three tasks. Now, that basically just says that MT0, the only benefit that it has is that it has MLM-based pre-training, and that says it all. MLM-based pre-training mattered here. Yeah. Further, what do you observe? You observe that this MTK instruct, this one, is actually much lower in performance compared to MT0 model. And that just basically, I mean, the MTK instruct model also uses multitask prompting actually, right? But then, this kind of stuff, the way to explain this is just that there is prompting style difference. The style in which MT0 model prompts versus MTK model prompts are way different. So leading to way improvements, way higher improvements across the two models. Way higher improvement for MT0. Models fine-tuned on XP3 are better than models fine-tuned on P3. And this is sort of expected that, hey, you're doing cross-lingual tasks. So therefore, you expect that if you fine-tune on XP3, typically you would observe that these models are going to be performing better compared to just the model which has been fine-tuned on English-only data, right? English-only prompts and English-only data. Now, so here are more details of some of those tasks. And some of those languages. These are particular languages which were never used, or rather, this task language pair was never used for fine tuning. Okay. So these are multitask fine tuning on XP3. So remember again, XP3 data basically contains English prompts for multilingual languages. So it does not contain, prompts in these particular languages. So these are performances for task comma language pairs which were never used for fine tuning, not for prompts, not for the actual data. Right? And what do you observe? These are all Bloom models, right? They are all, the last two are BLOOMZ models, meaning they have been fine tuned on XP3. These are the typical Bloom models, meaning they have not been fine tuned on XP3, right? They're just typical Bloom models. So not trained using prompted fine tuning, right? So what do you observe? You basically observe that yes, across all of these tasks, there is zero shot, cross task as well as cross language transfer, which is so great to observe, right? And in some cases, for example, this task in Russian, the performance improvements are massive, so significantly massive improvements. Now, my last thing is going to be talking about the best configuration in some ways, XP3MT, which is basically you're doing multitask fine-tuning, you're doing prompted multitask fine-tuning, your tasks are multilingual in nature, your prompts are also basically multilingual in nature. So now you're going to do multilingual prompting in a non-English prompt manner with multilingual or non-English tasks. Okay, so and here are these four different tasks which have been shown. What you also have is are the prompts in English at test time, right? Are the prompts MT or machine translated, or are the prompts human translated? In fact, it turns out some of those cases they also got prompts human translated, right? And then you see the accuracies for BLOOMZ and BLOOMZ MT. So versus MT0 and MT0 MT, right? So what do you observe here? So, you observe that BLOOMZ performs much better on English. So you observe BLOOMZ performs much better on English data, right? On English kind of prompts. So BLOOMZ performs much better on English than on non-English prompts. So non-English prompts, of course, you observe that BLOOMZ MT actually gives you better results. Non-English prompts, BLOOMZ MT is typically giving you better results, right? BLOOMZ MT is actually, better on multilingual prompts. So that's that. For MT0, however, the story is sort of mixed, right? For MT0, you see sometimes even on English, or rather even on multilingual case, you see that MT0 is performing better than MT0 MT. Right? So in English, the story is sort of for MT0, the story is sort of mixed, but BLOOMZ, it's very clear story, that if you have machine translated prompts, you see better results on multilingual kind of prompts rather than English prompt. Um, so typically, in XNLI, they also observed that human translated prompts actually gave better results compared to machine translated prompts. Now that's probably just for an XNLI, but at least that was observed. Okay. Now let's talk quickly about the scaling story. So remember, they have Bloom models which essentially can range from 560 million parameters to 176 billion parameters. So if you vary, what happens, right? So while MT0 models basically are available up to 13 billion, so up to 13 billion, so that's that up to 13 billion. So across different tasks, you observe a few things. So what do you observe? You observe that 560 million parameter models typically give you random classifier accuracies in some ways. So for example, random classification accuracies would be 0.5 for sentence completion and coreference resolution, 0.33 for NLI. So you observe pretty much, 560, the smallest parameter models essentially give you more or less random accuracies. However, and what you observe is that if you take the typical Bloom model, well, it does not really grow too much, right? It sort of gives you almost the same accuracies, even if you increase the size of the Bloom model. However, this is the power of multitask prompting or multitask prompting based fine tuning that as the scale increases, you see that the Bloom model, when it is done, BLOOMZ model, that shows you upwards trend, and MT0 model also shows you a clear upwards trend. In fact, MT0 models typically become way better very soon, or even 13 billion parameter models are way better compared to the 167 billion BLOOMZ models. Okay. So this was about a whole bunch of natural language understanding tasks. Do these models perform that well even on NLG tasks? Can they sort of improve natural language generation tasks also as well? Unfortunately, so not, right? So the problem is that, or rather, what you observe is that while these models, as you train them more and more, you observe that for NLU tasks, the average accuracy sort of increases, right? But for NLG tasks, the accuracy sort of decreases as you train them more and more. So unfortunately, these models have been sort of trained in some ways to generate very short outputs, and that is why whatever these guys tried, at this point did not lead to improvements in the NLG performance across translation, summarization, or even code continuation performance. So code continuation is basically I'm giving you a prompt and then try to write code based on that. So for all of these NLG tasks, unfortunately, the story is on the negative side that these models do not give you as strong performance improvements over non-multitask prompted models. Okay. Let's look at a few outputs. How do they look like? So here's an input, and the input is for explaining a sentence in Telugu. Explaining a sentence in Telugu, what is the backpropagation in neural networks, right? So sort of explaining something and in a different language. In general, mentioning the language as part of a prompt is a nice way of asking the model to generate output in that language, right? And you observe that that leads to reasonably good results using, let's say, the BLOOMZ model. Typically, MT0 models are terse in nature. You see MT0 giving you shorter results, but then BLOOMZ gives you reasonably good, nice, long results. Um, yeah, when you were doing things using XP3 data, remember XP3 data, there are multilingual tasks where the task input is actually written in different languages, and you're doing here multilingual sentiment analysis, but the prompt is written in English. Right? And still, these models work pretty well, right? But then these are the cases, some of those cases, these are the cases, for example, where the task is multilingual in nature and the prompt is also multilingual. So this is basically coming from the XP3 MT kind of a data where, task is multilingual and the prompt is also multilingual, Spanish basically, right? And you're trying to ask it to generate at least 5 related words, related search terms for a particular phrase. And the same task with the English prompts is basically right here. But then this is also multilingual task because the input of the task is not in English, but then, hey, that prompt is basically in English. Prompt is basically in English. So this is again an XP3 kind of a task. This one basically is fairy tale generation. It's a very interesting fairy tale. The idea is that you ask it to generate a fairy tale with a particular moral, right? And you ask it to generate the story in Spanish, right? So the interesting part is these models, you can actually prompt them to generate things in a particular language, prompt them to generate so many outputs. So in general, they are pretty awesome from a perspective of multilingual NLP. So let me quickly summarize. So in this video, we talked about two papers, one which and both of them on multitask prompted fine tuning. One we just focused on English multitask prompted fine tuning, so T0, T0 plus, and T0 plus plus. The other which focused on multilingual zero shot multitask prompted fine tuning, which led to models called BLOOMZ and mT0. Okay. For doing English multitask prompted fine tuning, you have a data set which is on English tasks only, P3 data set. But you could also do, multilingual, but you can also do prompted multitask fine tuning using English prompts again, but for multilingual tasks, which is XP3 data. And then finally, XP3 empty data set basically contains multilingual tasks as well as multilingual prompts for doing prompted multitask fine tuning. Okay, so XP3 empty, you can think of it as like multilingual, multitask, and multilingual prompts as well. So multilingual prompts as well. So that's that. So the broad understanding is that yes, multitask prompted fine tuning is great, right? Sort of helps you generalize across languages as well as across tasks. Right? Typically, you observe in case of English, you observe that this thing basically holds. So the number of data sets that you put in to do multitask fine tuning, you get better results. More prompts basically lead to better performance as well. So more data sets help, more prompts help in that senses. In the multilingual world, you observe that even if you do just English only fine tuning, still it improves the accuracy for other tasks as well as other languages. Now that's so awesome, right? So you fine tune only on English, but it improves accuracy on other languages. Great, right? However, fine tuning, of course, on multiple languages using XP3 improves further. And clearly, fine tuning generalizes to new tasks in languages that have never been seen before. So it's like a zero shot in both senses, cross task, cross language. Okay. Lastly, if you basically also fine tune using multilingual prompts, that gives you the best accuracies amongst all the models that we have discussed so far. Right. So that's that. So hope you enjoyed the video. Thank you for watching. Follow me on LinkedIn or go visit my homepage to know more about my research. Thank you.